Hi again here, working with you some more calculus information. Today we're going to talk about the limits, finding a limit in chapter 1.2 graphically and numerically. So here we go. Let's talk about an informal definition at first. We have if f of x becomes arbitrarily close to a single number L. So if the y values are getting arbitrarily or close to a specific L value, we call it L just because we need to give it some identification, right? As this x, as the x's approach some c from either side. So here are the x values. What are they doing? Da, 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 da. And here's the curve. Curve is happening. As they come closer and closer to some L value, then what is happening? Well, that's kind of what we have to ask is what is happening with these x's as we put them into the function? What is happening to the y values? So what is the behavior of y's with respect to each x? If it approaches some c from either side, then the limit of f of x as x approaches c will be that L value. Really, we're just looking at what is happening with the x's, what are they doing in y's, and as we get to one specific x value, what's happening in that L or that y value range. Okay, we write this as the limit of x as x approaches some c of the function f of x will equal some L. All right, well that's the formal or informal definition. So let's kind of see what it looks like if we do an example. So example number 1 is where we have a function right here. We have f of x equals x over x plus 1 minus 1. That's our function we're looking at. And numerically, we just build a table, okay? And as we start plugging in x's from the negative side, remember we have to go from the negative side or the positive side. They have to go both directions. As we approach 0, because we want to know what is the limit as x approaches 0, what's happening with these y values? Well, with negative 0.01, we get 1.9949, 1.995, and as we get closer and closer to 0, we can see it 1.999. If we go the other direction, and we have bigger x values here, to get smaller and smaller and smaller and smaller to close in on 1, then we can see that these values start getting really, really, really close to a value of 2, right? So 1.999, almost there, and then this would be about 2, and then 2 right after. So what we would say is the limit, the y values, as x approaches 0 from the right and the left of this function is equal to some L. Well, that L is in fact 2. All right, well, let's see if we can. That's a numerical approach. Building a table takes some time usually. So let's look at it graphically and just see what happens on the graph. On the graph, we can see that at negative 1 and 1, this function looks like this. It's the blue line. Here's our function. And as we approach from the red, from the right or from the left, we can see that if we put 0 in, or any number close, then like our table showed us here, we would get close to 2. Now, even though it's undefined at x equals 0, because if we put 0 in, it would be undefined, we still say that the limit is equal to 2. So that's a way to look at it graphically, what's happening between these two. All right, let's look at another example where we're asked to find the limit of f of x as x approaches 2. Now we've got some kind of piecewise deal going here where the function, if the y value is going to be 1, then x cannot equal 2, right? However, if the y value, right, these are the y values, what's happening at x equal 2? Well, the y value is going to be 0. And we just get a horizontal line, right, here. And it tells us, though, that at x, the y value is 2. So we have a solid dot there. But the function also is undefined at 2. It's kind of weird. How does that happen? You might be asking. Well, that's a discussion for later. But the limit, we're talking about the limit, as x approaches 2 from the right and from the left, what are we getting closer and closer to? Well, we seem to be getting closer and closer to a y value of 1. All these values here for these x's all go up and hit 1. And so we can say that then the limit is 1. All right. Hope you enjoyed the video. Have a great day. Talk to you soon.